Alright, this is video 5. Alright, and here we go. So we're looking at trigonometric ratios. And here the main thing is to find your indicated angle, label it O, H, and A, and figure out if you're using sine, cosine, and tan. Okay, so we have our primary trig ratios and our reciprocal ratios. We have sine, cos, and tan. We should know those ones. And then the which are the primary trig ratios. And then we have the reciprocal ratios, which are the opposite. So 1 over sine, which is with cosecant, 1 over cos, which is it with secant, and 1 over tan, which is it with cotangent. We can see that sine and cosecant, C and S go together, but no S and S or C and C. All right, so here we're just stating the primary trig ratios and their reciprocal trig ratios. The big thing here is if you're dealing with any square root sign, that you leave them in exact values and you don't change them to decimals. And then after that, if you have a square root on the bottom, that means you have to rationalize. Okay, here we're just looking for tan. Here we identified the triangle, or the angle X, and then we label it O, H, and A. And then if you're ever looking for an angle, you have to do the inverse. This is what we found here. In order to find any other angles within the triangle, we look at 180 minus 90 minus 58 in this case, or 180 minus 2 angles gives you, or 1 angle gives you your other angle. If you're looking for the denominator, you divide. If you're looking for the numerator, you multiply. Okay, so it's kind of showing you the biggest questions. All right, going on to day 2. So for day 2, we looked at solving triangles. Solving triangles means you have to find all the angles and all the side lengths. Here we're looking at SOHCAHTOA, primary Pythagorean theorem, and ASTP. All right, so for this question, we're solving for x, y, z. We have a 90-degree angle. Again, labeling the triangle OH and A, and solving. These should be good. You should be good with these types of questions. For this type of question, the whole thing, if you have 2 different triangles here, is trying to find what they share. Here we have this line in the middle that they share. So in order to move from one triangle to the next triangle, you need to find what they share. So here you can use finding the longest side first, and then from there finding that inner side. We will be looking at using sine and sine law and cosine law, which could help finding H as well. All right, and then for this one, we did on the exam review, sine law and cosine law. So sine law would be your helicopter law. We went over it here. So you can have side, side angle, or angle, angle, side. There's no right angles in sine law. However, you can use sine law if you have a 90-degree angle triangle. Or you can use sine, cosine, and tan, but it can't be, you can't use sine, cos, or tan on a non-90-degree angle triangle. Right, then we also looked at cosine law. So cosine law would be like that sandwich law, or if you have all 3 sides. So if you have the side and angle and side, and you're looking for that opposite side, or if you're looking for any angles, you're going to use sine law. Again, those are given on your formula sheets as well. All right, and then here's a good question here. They only give you 2 angles and 1 side length. Don't forget, if something like that happens, find the other angle, and then again, you have sine law. All right, trig application, we're looking at elevation and depression. Elevations from ground up, depressions from ceiling down. All right, and then here again, we did a sine law question. They're using SOHCAHTOA. If you're standing on the building, you're looking up, it's elevation. If you're looking down, it's depression. To find how tall it is, you did 2 tans here and added them together. Again, for this type of question, the 2 helicopters, find what they share is always my hint. Ambiguous case. So the ambiguous case would be like your grade 11 question. This is different from grade 10. All the other ones were grade 10 type questions. So you have 3 kind of cases that are happening here. You have no triangles, 1 triangle, or 2 triangles. We're going to use the formula H is equal to B sine A. So H is equal to B sine A. If A is smaller than the height, then there's no triangle. So if your A, which is here, so set it up with B, A is your angle, opposite A is what we're looking at. And then if A is smaller not going to have a triangle here. If a is equal to your height, this is how you find your height. Height is equal to b sine a. Then it's going to be equal to one triangle. And if a is bigger, so if a is bigger, then you can have two triangles. Let's talk about that. So having two triangles means that this a line right here, right, this a line right here can swing. This a line right here can swing to here to here. It's almost like a pendulum. So then you'll get some this triangle right here. Okay, so that A line here, you'd find the acute angle, and then from there, you would swing to get this isosceles, isosceles triangle, and then you will have to find this angle as your new case. So there's two triangles that happening, and we kind of get rid of that isosceles triangle. Okay, so let's look at that. So the first part here is just saying to find A if there's no triangle. So H is equal to B sine A. B is your side that's on top of A. And lowercase a is across from the angle. And we want to see if A right here, putting in B sine capital A, is bigger or less than that side. And we can see that we get 12 here. And we get 12.2 for the height. Well, since the height is taller, obviously there's going to be no triangles. Right? Then it wouldn't touch. Like if that's that's a shorter side and that's a longer side, then this is not going to touch. It's not going to make a full triangle. Right, and then for here, even though we're given different letters, you can always change it to A, B, and A if that's what you want. So this would be A, this would be little a, and this would be B if that helps. You're always given an angle. It's across to its opposite side and then another side. So this other side and this angle, we want to see if this height is bigger or smaller than the opposite side length of your value. So we can see here when we figure out h is equal to b sine a that again we get no triangles. But 10 is smaller than, and we get our height is 15.6. Again, 10 is smaller than 15.6, no triangles. All right, let's try this one. Again, if you want to, you can change this to A. This is lower a, and this is B. How do I know that? It's because P and P go together. This is the angle on the opposite side, and then this is the other side. So again, if you want to draw it, this would be 42.6. We don't know the height. We're trying to figure it out. We want to see if the A connects. This is 25.6. We don't know if it connects or not. It depends on how tall this is. And this is your opposite side, 35.4. Right, when you did that, you get 24 as the height. So 24 is smaller. So that means, yes, that is going to touch. Right, it's going to be there, but it could also be over here. So 25.6 could be here or here. You can be in the first triangle, which would be like your acute triangle, or you can make that obtuse kind of triangle. And then you'll have to sign all the side lines. And angles. All right, and then we're looking at angles in standard position. Complementary angles are 90 degrees. Supplementary angles are 180. I know. Okay, so here we're just trying to find the following. So you're just typing those into the calculator. Sorry, it was noisy before. Class is over now. All right, so very important that we're looking for the initial arm, origin, terminal arm. We're always going counterclockwise. So here, the initial arm is always the positive x-axis, and then we're finding a theta, and then we have the terminal arm. Terminal arm could be anywhere. It could keep on even spinning around and around and around. So R is always the radius. We're looking at the CAST system, which is CAST. Cos all, or it just means where all the angles are positive. Cos positive here, all are positive here, sine's positive here, and tan's positive here. X squared plus y squared equals r squared. That's really important. You should know all of these, right? Especially like sine, cosine, tan, and then just the flips of them give us secant, cosecant, and cotangent. And then here what we're doing is we're plotting the point and then finding where this occurs. Don't forget, if it is square rooted, that you are rationalizing. Here it's not rationalized, but please rationalize and reduce your square roots. So reducing the square root of 68. 68 is 4 times 7, so the 4 times 17. So the square root of 4 is 2, and we're left with 17. So that should be there instead of the square root of 68. Remember to put them on the denominators here too. If it's on the denominator, you are rationalizing how to rationalize. So this would actually be 8 divided by 2 square root 17 is reduced. Then to rationalize, we're going to multiply the top and bottom by 17 square rooted. The 17 here and 17 here gives us the square root of 17 times the square root of 17 gives us just 17. So 8 divided by will be 2 times 17. And then on top it just stays at square root of 17. And then 2 times 17 is 34. So we get 8 square root of 17 over 34 would be our answer for sine theta. Okay, same for secant. Do the exact same thing, but here you don't have to rationalize it. You do have to reduce it to root 17, but you don't have to rationalize it. So this would be 2 root 17 divided by 2. And then the 2's cancel out to give us a square root of 17. Okay, so continuing this. So we've discussed things like this before. Square root of 58, don't forget to reduce it and then also rationalize. When you're looking for the theta, remember that it's CAST. Here our letter that we're looking at is CAS, so S for sine. So we're going to find the sine of theta of 7 over square root of 58 by using the inverse. But this is not our angle. This angle right here is theta, which is in this lower or smaller triangle. How do we know that? Because we're looking for O and H, O being 7, the H being the square root of 58. So we are using sine here. And then from there, once we find 66.8, we're going to do 180 minus 66.8 to give us actual angle theta. If it was down here in A, you would do 180 plus whatever your theta is. And if it's over here, 360 minus whatever the angle that you found is. So if it's in the first quadrant, leave it. Second quadrant, subtract 180 from it. Third quadrant, add 180 to it. And then fourth quadrant, subtract 360 from it. Okay, let's keep on going. Some trig identities. So you should know all these by now. A couple of trig identities, we can see on the formula sheet that they are not there. So you should know that secant, cosecant, and cotangent. The quotient identities look like tan theta is equal. It's sunny, so sine is on top. In order to get a tan, it has to be sunny. So sine's on top over y. Sunny, sun, sine. Sine is y, yeah, over x, right? Tan is equal to y over x. Sine is y. Just like in the unit circle, sine is y, cos is x. And then cotangent is cos over sine, the opposite. You should also know these Pythagorean identities. Sine squared plus cos squared equals 1. It's not sine plus cos equals 1. It's sine squared plus cos squared equals 1. And then you can rearrange them to get sine squared and cos squared by themselves to get sine squared is equal to 1 minus cos squared, and cos squared is equal to 1 minus. All right. Looking at some identities, you have to do left side and right side. So on the left side, we can see that we have sine cos, and which gives us y over r, which gives us x over r, and then we found tan, or tan theta is y over x. All right, so anyways, things are going to look a little bit more like this. So we have left side or right side, cotangent and sine. Cotangent is cos over sine, sine is sine, so these are being multiplied. Sine and sine cancel out, and we're left with cos. Left side equals right side, and if you want to, you can throw in QED, but you do have to definitely write left side equals right side. This next one, we have cos over cotangent. So we get cos over, anytime you see cotangent or tan, change it to sine over cos or cos over sine in order to simplify it a lot more. Same with like something like this. Here we have 1 minus cos squared, but remember that 1 minus cos squared theta, this is only 1 minus cos, is sine squared theta. So you can't just change this to sine squared theta because it has to be a squared there. All right, so here we just distributed, we changed the secant to 1 over cos distributed and found that it's 1 over cos minus 1 by using, like combining the denominators together, and we get 1 minus 1 over cos minus cos divided by cos is 1, and then here secant minus 1 is 1 over cos minus 1. Right, and then for this one, what we did is, again, left side and right side. You can't move anything over the equal sign. It has to be divided into left side and right side. So here we get, we can see that there's some things that are squared here. So, and there's no cos over here. So changing that 1 to be sine squared plus cos squared is smart. And then from there, we distributed the negative and found that we get sine squared plus cos